Okay, so now this is maybe later, right? It's rolling along, and it's got potential energy because it's not at ground zero. It's got velocity, and the question is, what is its speed up here? It'll have potential energy, and since it's moving, it'll also have kinetic energy, right? So this is a 2 to 2. This is mgh plus 1/2 mv squared. So this has, since it's moving, it's got kinetic energy. Since it's not at the lowest point, it's got potential energy, potentially, right? And then here, it's also not at the lowest point, so it's mgh. And it's moving at the top, so it's got 1/2 mv squared, and nothing else. There's no mention of a force. There's no mention of springs, right? Okay. So let's cancel our masses, which we can do. We can do that. We can divide everything by mass. And I've got 9.81 times 2.15 plus 1/2 8.6 squared equals 9.81 times 4.25 plus 1/2 v squared. So I'm going to do this whole left side. I'm going to go 9.81 times 2.15 plus 0.5 times 8.6 squared. So the left side's 58.075. Now I'm going to subtract this term. So minus 9.81 times 4.25. And now I've got 16.379 is equal to 1/2 v squared, right? So what I did was I did this whole side in one swell foot. Then I subtracted this term and I got this. And now I'm just going to multiply by 2, and that's what v squared is. And let's square root that. And I get 5.72, so v is 5.72346 or something like that. Anyway, so my strategy when I do the maths on this in the calculator is I start on the side opposite the variable, and I first get that entire, whatever that side is, right? I just do that and get a number, right? And in this case, it was, when I did that whole left side, it was 58.075. Then I subtracted this term, so subtract all the terms that don't contain the variable, right? So I subtracted this term from it, and I got this, and then you have to multiply, divide, square root, right? Anyway.